Okay, so problem number 6 is a compound inequality. So this is two inequalities combined. So our goal is to make the middle here just x by itself. So I'm going to subtract 1, and whatever I do to the middle, I want to do to both sides. Now I have a 4x in the middle. I want to get x by itself, so I'm going to divide both sides by 4, and I'll get negative 3 is less than x and is less than 3. Okay? So this is what we will use for our inequality notation here. Solution, part A. And then it asks us to graph the compound inequality. So remember that if you use this symbol or this symbol, the greater or less than, you're going to use an open circle. Okay? If you use less than or equal or greater than or equal, you're going to use a closed circle. Okay? So in our case, we have less than. So I'm going to use two open circles. And our solution is between them, so I shade that in. So that's part B. And then part C says write an interval notation. Our farthest left value is negative 3, and our farthest right value is 3. Okay? Now, to decide if we use a parentheses, if we have open circles, we're going to use parentheses. Okay? If we're going to use the closed circles, we're going to use brackets. Okay? So in our cases, they're open circles, so I'm going to use parentheses. That's problem number 6. Number 7 is a system of equations, and it says to use elimination, but you may use whatever method you like. You can use substitution, you can use elimination, you can use the graphing on the calculator, your choice. So if you want to use the elimination method, that means you're going to add the two equations and eliminate a value. Well, the way it's written right now, if you added the two equations, you would not eliminate anything. But if I multiplied my first equation times negative 9 on both sides, then it would become 27x minus 9y is equal to negative 45, right? And if I were to take these two equations and I were to add them, then I would get 0 is equal to 0. My variables would both be eliminated. When both your variables are eliminated, if you have a true statement, which 0 is equal to 0 is true, then you know that you have an infinite number of solutions. Now, if you combine your two equations, a little side note here, and you end up with a false statement and no variable. So for example, you end up with 0 is equal to 10. This is false. If you end up with a false statement and you have eliminated both variables, in other words, you don't have one anymore, then this will be no solution. We know that there are 3 different cases on systems. Sometimes, when you graph your two lines, they intersect clearly at this point, and this will be your one solution. This will be an ordered pair. It'll be one solution. Sometimes when you graph them, you'll graph the first line, and then you'll graph the second line, and you'll realize that they're the same line. When they're the same line, that means you have an infinite number of solutions. They're the same line. And then the third scenario is you graph the first line, and then you graph the second line, and they're parallel. And parallel lines means that there is no solution. They'll never have anything in common. So those are the 3 cases that you may get. Okay? Now, you can use your calculator for this one, but when you enter it in the calculator, you have to realize that you're solving for y. So for example, for this one, if you entered in the calculator, it would have to be I'm going to add 3x y is equal to 5 plus 3x. I can enter that in the calculator as my first equation. And then my second one, I'd also have to solve for y. Okay, and this would be y2. Okay, well, I can clearly see they're the same equation just now looking at them. But I could enter them into the calculator. Let me just show you how that works. Whatever equations you're given, you could enter into the calculator, and then you could graph them and take a peek and see which of those three cases you have. Well, you can clearly see that I'm only getting the graph of one line. If I look at the table, second graph, it shows you that for the same input, every point has the same output. So it's clearly the same line, okay? So ours, since it has it's the same line, it will be an infinite number of solutions, okay? Let me just show you, though, this is not the one we have. Let me just tweak this a little bit to show you, though. For example, if you had one that looked, let me give you one here. I'm just gonna change it to an example of one that will have an intersection. So I just made those up. But if you have two lines, you can clearly see in this case they have an intersection. So if you clearly have an intersection, you can say second trace 5, and then say enter, 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 and it will give you the intersection. So in our case, it's negative 2.5, negative 1.5. This is just a problem I made up. It's not in the practice test, okay? And let me just make up one more problem to show you what happens when they're parallel. So I just made up two lines. And when I graph these, you can see that they're two separate lines, but they're parallel. So they would have no solution. So those are just three of the three cases. On the practice test, it just happens to be infinite number of solutions, but yours on the real test may be one of the three cases. Problem asks us to graph a linear inequality. Okay? So we graph a linear inequality exactly the same way as if it were a linear equation. So I know that if it were y is equal to mx plus b, so if it were y is equal to 1/3 x plus 1, m is 1/3, and our y-intercept is 1. So I can graph that right here, 1. And then I'm going to go up 1 over 3. So my slope is always rise over run, so it's going to go up 1 to the right 3. So I'll go up 1 and then to the right 3. And I can graph that. That's one way I could do it. The second way I could graph in a line, remember, first of all, we're just graphing it as a line, is I could use my calculator, okay? So get those calculators out. Let's try them again. Clear whatever you have. Now I can enter it in as 1/3 x plus 1. And I could graph it. And you can see what it looks like. But that won't help me graphing though, will it? But if I say second and then graph, it gives me a table. And this gives me points. So now I could enter in 0, 1, and I could enter in 3, 2. Those are easy ones to put in. I don't enter decimals in typically. I would choose points that are integers. Okay? So that's one way, an easy way to quickly graph that line. But we don't really have an equal, we have a less than. So we have to realize that if it's less than or greater than, we're going to use a dashed line. Okay? If it's less than or equal or greater than or equal, we're going to use a solid line. So in our case, we have a less than. So we shouldn't have used a solid. Really, this should be a dashed line. Okay? Now, the next thing we need to do is to decide which side we're going to shade. Okay? With an inequality, you're going to shade either above it or below it. If your equation is solved for y, then all you need to do is look at the sign. If it's less than, we're going to shade below the y-intercept. If it's greater than, we're going to shade above the y-intercept. Okay, so ours is less than, so I'm going to shade below the y-intercept. So remember, this really can keep going on when you put it on the computer, it will. And so I'm going to shade this side. Now I can also check that with a test point. That's a different method. If you're a test point person, then what you're going to do is you're going to enter in 0, 0. So in other words, you're going to put in a 0 for y and a 0 for x. So I'd get 0 is less than 1. If that's true, that means that 0, 0 is part of the solution set. So in our case, it is true. And you can see 0, 0 will be on this side, and you would shade that side. If it had been false, you would have shaded the other side. And that's called the test point method. Number 7 is a factoring problem, which is a nice little quickie factoring problem. And when we factor, we always look to see, first of all, if there is a greatest common factor. Well, in this case, there is no greatest common factor. I know that because one of my coefficients is 7, and I can see that clearly not all of them divide by 7. Okay? So next, I count the number of terms. I have 1, 2, 3, 4 terms. When you have 4 terms, you have to use factor by grouping, and they'll give you this prompt anyways. When you factor by grouping, all you need to do is you break it into 2 mini problems. So I'm going to first look at 7x squared plus 14x. And I'm going to factor out the greatest common factor. And in this case, my greatest common factor is 7x. So I'd have 7x times x plus 2. If you're struggling with this, write the prime factors above each term. And that's the bottom of the factor tree if you make a factor tree. And then look what they have in common. They both have a 7x. Whatever they have in common goes in the front. That's your greatest common factor. And whatever is not circled, these are going to be what your terms are, x. And then 1 times 2 would be 2. Okay? And if you're still struggling with these, you are welcome to email me and I'll send you more videos. I'll find them on the internet for you, or go see the math spot. Now, the second part of our problem, 2x plus 4. The greatest common factor here is 2, and I'd be left with x plus 2. So 2 times x plus 2 is 2x plus 4. Once I have them factored, I reunite the 2 sides. And I look for what is my greatest common factor. Well, now the expression x plus 2 is my greatest common factor. Whatever I haven't circled, whatever is not in common, becomes my terms in my second binomial. And I can always check these by multiplying. So if I wanted to check it, I could just distribute. And I need to make sure that I end up with the same problem that I originally started with. All right. I also want to show you a different method if you're struggling with this. Some people like to draw a box. You have 4 terms. You put the first term in the first box and the last term in the last box, and then your other 2 in either of the other boxes. Okay? Now, you want to look here in this row and say, what is your greatest common factor? Well, my greatest common factor here is x. Okay? Then you look at this row. And my greatest common factor here is 2. Okay? Then I do the verticals, and I look for what do these have in common vertically? What is their greatest common factor? Well, they have a 7 and an x. And then finally I do that last column and say, what do they have in common? Well, their greatest common factor is 2. Okay? Now, whatever you're touching will tell you the sign. So, for example, 7x is touching 7x squared. That's positive. 2 is touching 2x, that's positive, so that's positive. And this also will be positive because it's next to 14x, and 14x is positive. So my factoring is 7x plus 2, which is my top row, times x plus 2, which is my column. We get the same answer, just a different way of getting there. And you could also check this one by multiplying. Problem number 10 asks you to simplify a rational expression. To simplify a rational expression, you need to factor the numerator and the denominator, and then divide out any common factors. So, x squared plus 8x plus 15. If I factor this, it's x plus 3 and x plus 5. If you're struggling factoring this, you can use the AC method, you can use bottoms up, you can use reverse FOIL, but you need a method. And if you don't have one, please visit the Math Spa or come by and see me or email me for videos. And then my denominator, this is a difference of squares. So a difference of squares, remember, is that a squared minus b squared. You can just jump to the factoring. It's going to be a plus b and a minus b. But if you're struggling on either of these, please get help before the final exam. So what do they have in common? Well, the factors they have in common are x plus 3. And that would leave me with x plus 5 over x minus 3.